and no reply. So let's just take a step back there. What's Molesy? Molesy is a mobile app aimed at providing you with a shopping experience from hundreds of different retailers with a Tinder interface on top. So you can swipe left and right on clothes. And when you swipe right, the products get saved. And when they drop in price, you receive notification. You can go and buy them when they're cheaper. Um, so it's been around for about 3 years now. I've been there for pretty much 3 years myself as well. So pretty much from the very beginning. Molesy has been featured on Dragon's Den, and it's been in Forbes magazine, and even on the Angel of the North. At the moment, we've got about 60,000 monthly active users. Oh, by the way, we almost got sued for this really badly, but we didn't. So that's good news. Um, at the beginning, we had much less than 60,000 users, and when anyone know what film this is from? James Bond, Skyfall. So beginning, when you're a startup, you have big dreams. You're like, oh, I'm the first engineer. I need to build a massive server. All right, I need to have everything running on my own hardware. Then you realize that as the only developer, you just can't. You don't have the time. You'd like to be Raoul Silver. Look at that smile. Why wouldn't you want to be him? But you can't, and you soon learn about the concept of SaaS, software as a service. This is the idea that you can pay someone to spin up pretty much whatever you want. So, for instance, if you wanted a MongoDB cluster, you could pay these guys, MongoLab, however much for whatever you want, and they would spin up a nice cluster for you. So small you can't see that, but basic concept of it. So at the beginning, our stack looked very much like this. We had a Node.js API, and that was running the Happy.js framework, which gives you stuff like validation, caching, all the nice things for free. It's really nice. We're using the MongoDB database. That was used for all of our user authentication, all of our brands, all of our merchants. And initially, it used as a product catalog, and we soon realized that MongoDB for a product catalog just doesn't work. So we moved quickly across to Elasticsearch. Elasticsearch is great for full text searching, for aggregation. So, for instance, if you were to search for a particular term, it then show you the breakdown of what fits into dresses, tops, jeans, all this kind of stuff. It does that really, really quickly. Redis cache for basic caching. And that drove our non-native PhoneGap app, which is for both Android and iOS. So I mean, it was a hybrid app. It wasn't great, but the point is, as a startup, it's about shipping. You ship fast, you ship early, you get it into the hands of users as soon as possible, and you know, investors love this. Now, whilst this looks like a relatively simple setup, you could essentially have all of that, apart from obviously the app, running on a single server, and that's the way a lot of people would do it. But again, we were using SaaS. We didn't have time to set up production clusters for MongoDB, Elastic, Redis, Node. There's just no time to do that. So we used a whole load of different software as a service providers. For MongoDB, all the SaaS. I keep forgetting to put that in there. So for MongoDB, we've got MLab, or MongoLab as it was known. For Elasticsearch, we've got Elastic Cloud. And for Redis, we were using Redis Cloud, and the Node server was running on Happy.js, was running on Heroku even. So we were using a lot of third-party things, and that was fine for the time being. It's worth mentioning at this point as well that this doesn't have any of our kind of data acquisition stack. This doesn't have any of the web scraping stuff, any of the feed processing stuff, any of the data processing at all. And if you can imagine having all that stuff, more reads and writes to your database, and you can imagine that the database contention was a lot higher than just a simple database. There's a lot going on all the time. And when your team goes from this to this to this, when you've just got like 25 plus people and you're all working on the same product, you realize that the needs for your team also completely change. We recently, well, I say recently, it was about 2 years ago now, we hired our data scientist, Martina. When she first joined, she was like, "Oh, bro, can you give me all of the swipes for all of time?" I was like, "What?" That was into the hundreds of millions at that point. And at that point, there wasn't really much I could do. There wasn't really an easy way to get that data out of the database without literally querying it, doing a dump of the database, which would put strain on it. And when you've got a relatively small user base, you can't really be affecting their experience. As soon as you start affecting their experience negatively, they decide that they don't want to use it, and that's not what you need in the early days of a startup. So we realized that we needed a new stack. Um, so we needed a new stack as well to drive our actual native apps. So we got an Android app and a native app, and we build those in house. And that's what we were doing. So the first thing we needed to do, like this, the first thing for Martina, she needed the swipes. She needed them real time, and she needed the most up-to-date version of them. And she needed a way to be able to export them at any time without fully affecting it. So we chose DynamoDB, and that's a service from Amazon Web Services. And the benefit about that is that it's fast, scalable, distributed, and any other service from Amazon can hook into it. So for we could send all the data which is happening in that into a stream for anybody in the whole company to consume. And there can be multiple consumers, which is perfect for our use case. And the other thing that we need to do is we need to start moving services in-house. So for instance, Elasticsearch, that was being hosted in Elastic Cloud. Now, incidentally, something terrible happened a day before Black Friday last year. We'd managed to find a bug in the actual Elasticsearch code, which was cause the server to crash consistently every hour for 30 minutes at a time. And that was the worst. Like, what you meant to do with that? There's nothing you could do. At that time, because we weren't hosting it ourselves, we couldn't SSH into the box and diagnose it. We couldn't restart it. They didn't even have the facility to restart the whole server. We were literally at the mercy of a third-party provider, and that's just not what we needed. So we moved all that stack to EC2. Amazon do offer Elasticsearch hosted setup, but again, we wouldn't have had the access to be able to get into it if we needed to get into it. So we decided to run EC2, and it's at that point I realised that this beard is here for a reason. Like DevOps, it's not what you want to be doing, but it happened. The next thing that we decided to do was we decided to move in-house API. And our API was running on Heroku, and that's great. It allows you to scale up really quickly. It allows you to basically set the number of instances that you've got, and that's great. You can adjust it in response to demand, but you have to manually do that yourself. Now with Amazon, they have this called Elastic Beanstalk, and that basically allows you to deploy like any code you want and any you want. So there's JavaScript, there's Python, there's Ruby, pretty much anything, and also it allows you to deploy Docker images. The cool thing about that is that you've got your full environment in a single Docker image, and you can just spin it up wherever you want, give it as many instances as you want. But the other cool thing is that it can scale in response to whatever event you want. So it could scale in response to CPU utilization. It could scale in response to throughput. And the benefit of that is that then you don't have to worry about it ever, like, about going in when it's busy and changing it. It does that automatically. You can reliably just know that it's going to do that, which is perfect. So we got this up and running. But as with anything like this is like the full API we're talking about. We were a little bit scared to roll it out. So we didn't. We just had it sat there waiting for a time when we could be comfortable enough just to roll it out. So, back to the 9th of September. Ross, he's here. That's him. This is why you shouldn't take photos of my phone, Ross. He was the one responsible for setting up the stack, the Elastic Beanstalk stack. And he's the guy who I phoned, or who I contacted when things went wrong, but he still wasn't replying, so I phoned him. His reply to me was pretty much my words to him: shit, what's happening? We didn't know. We looked at the Heroku logs, and Heroku was receiving no requests. And we knew that at that point it was nothing to do with our code, it was nothing to do with our systems, it was to do with Heroku themselves. So, the first thing you do, you head along to their status pages, and their status page looked like, that was our API. You could see that we just had no requests going in. A 10-minute period where we just had no traffic whatsoever, and again, there was nothing that we could do. So, like I say, we went to go and check Heroku's status pages. Just a sec, and they looked like this. Um, it looked completely fine. Everything was reporting normally, and that's not what we wanted. So once we eventually rolled out our own Beanstalk configuration, and once we actually flipped across the DNS, we were fine. So that's the DNS propagation come into effect. We had a 2-minute TTL, time to live, on our DNS, and that means that it took just 2 minutes for those changes that we made to our DNS address to just propagate across the world, which was perfect. And you can see exactly that happening in that crossover period there. So 3 instances came up, um, and it worked really well. So like I say, we went across the Heroku. They were reporting everything is fine, and it was so annoying because everybody knew that it wasn't fine. And we're headed to Twitter next. You can't really see these, but there was a lot of people. The search term is Heroku down, and there was a lot of people talking about Heroku being down on that day. Uh, and this is probably one of the worst ones, one of the most prolific things that happened. Deliveroo, obviously a massive startup themselves, they were hosted on Heroku as well. They went down. They were down for over an hour, and like this was what their main website, their .com website, reported. It was just an Nginx error, and that's not really acceptable for the likes of Deliveroo or a big startup. Um, so I think that it's quite on the fact that we were able to, first of all, deliver our users a decent error message. The error message in the app was something along the lines of unable to connect to MultiHQ right now, try again in a minute. We were able to recover in just 7 minutes, so it took 5 minutes to diagnosis and being alerted to the issue. And then it was 2 minutes actually the proper DNS propagation once we knew what was going on. Um, and yeah, we were able to get everything up and running all within that time. And I guess the 3 main points of this whole talk is, yeah, exactly that. Always have a production ready backup ready to go if you can afford it. Obviously, it's expensive to have 2 concurrent setups running on different providers, but for us, it proved invaluable. There's no other situation when that would have, when anything else could have happened. The next thing is have short TTL times on your DNS. If you ever need to flick across, well, you might have everything up and running, but unless you've got a short TTL time, it's just going to take ages for anything to propagate, especially when it's got to get all the way around the world. The next thing is, yeah, have good error messages to let users know what's going on. It's common knowledge. It's good. It makes sense. But unless your users know what's going on, they assume the worst. And especially when, for instance, us, we deal with clients' cards, we deal with their orders. It's a lot for them to entrust to us. So, yeah, we're still running on that stack. Um, And I mean, this is what we're currently looking like right now. So this hopefully it's not stopped. That's users currently using Halsey right now. The reds are hides, the green dots are saves, and blue is anything else. Just a second for in particular, so give it a refresh. So yeah, that's me. That's a really slow internet connection. But yeah, have you got any questions? Go. Correct. How would you have a structured backup that included the database and the latest data? So the cool thing about DynamoDB in particular is the fact that, okay, of course, Dynamo, if that goes down or if AWS go down, well, you've got bigger problems. But again, the cool thing is with Dynamo is that you can create what you call a Lambda, which is just a little bit of code to trigger off on any event you want. So whether it's an insert, a modify, or delete. And the cool thing about that is that that can then replicate into another third-party database, whether that's Google's Cloud or Azure or anything else like that. So it can be fully replicated. And again, that's the same with the Elasticsearch setup. So you could have that. It's something which we're thinking about doing. Obviously, keeping it completely small scale on Google's side until we need it. The benefit of using things like DynamoDB and Google Cloud's that it's really easy to scale up and down as you need it. So you could very easily say that once you go into production on that particular platform, that you want to scale everything up, and then it adapts to that, which is perfect, exactly what you want. And again, you could have another thing listening on that side, which then replicates into your Elasticsearch cluster. So it's really, really good stuff. Yeah. Yeah, so the impact was, so right there at that point we were receiving about 300 requests per minute, which is pretty low for us. Right now we're probably, let's see, just move this across here. Where are we? I think right now we're probably at about between 750 and 1,000 requests per minute. Don't even know where my window's gone. But so it's probably about that. And so 300 at that particular time was pretty low, but that's usually about between 60 and 100 users at that time. So yeah, it was, for us, that's a massive impact, especially when you just can't access your app at all. There's no part of it. No, thankfully, because we were down for just 7 minutes, it's enough time for an app like that to have a Tinder kind of interface that people will quite happily go away from it and then come back later on because they still want to have that swipe interface and they still enjoy that. Hi. To have a load balancer across multiple instances of the API, or?
So you said that you have two production-ready environments.
Yeah.
So if you have a load balancer in front of them to avoid the error speech.
Yeah, so I mean that's one thing that we could do, but that introduces extra latency when, and a lot of the time you just won't need it. It's much, I mean, you can afford to have 2 minutes of downtime in order to flick across, in order to flick across the production API and reduce latency. I mean, that's the thing. If you've got a load balancer running in, I don't know, Amazon, for instance, then if that needs to go to Google, you're going to have introduced the massive latency. So for us, it just doesn't make sense, especially considering the amount of traffic that we get for swiping.
I was more saying load balancing, not to split the traffic across the environments. So when one production, the main one that is alive,
Yeah, if that fails.
It automatically switch to the other one.
Yeah.
So then, so just you just keep the
Yeah.
your primary going down.
Yeah, we could definitely do that. But again, what happens if the load balancer fails? It's the type of thing which it's probably very rare that it's going to happen. But if it does happen, again, you still need to switch across your DNS. But yeah, it's probably a good shout. Just in the short term, if it does default to your second production cluster, then yeah, it'd be a good shout. Definitely. Alex.
Given that if you had all the money in the world, what further improvements would you make?
I would more Elasticsearch servers in particular that deals with a lot of the traffic for the requests, but also every single swipe also gets stored in Elasticsearch. So users need to be able to see their saved products. So we actually create a copy of the product in our database and insert it into the user's collection. So there's a lot of data currently in Elasticsearch, and that all needs to be queryable and actionable at the drop of a hat. So I'd add more to that, but then I'll also have a complete replica of the production environment on a completely different provider. Okay.
Search. I read recently that some data is not very acid.
Yeah, so neither is Mongo. MongoDB isn't ACID. Elasticsearch isn't ACID. Elasticsearch is a complex beast. So you can have multiple machines, but on each of those machines you can have, and that the multiple machines make up a cluster, and then within there you've got your indexes, which are kind of like tables in most traditional databases, but then each table has got multiple shards. And is what you can do with that is you can say for this particular index, I want to have 2 replicas. So what it does is it distributes all. Let's say you've got one index, one table, and that's made up of 5 shards. It will copy each of those 5 shards to the 3 different instances of Elasticsearch. Okay, and it'll make sure that there's more than. So this is the primary for shard 0. This is the primary for shard 1. This is the primary for shard 2. And it'll distribute them evenly so that if any data loss does occur on any particular shard, it can easily restore it from from another shard on one of the replicas. So data loss is very rare, and it totally depends on how you set it up. If you follow Elasticsearch's advice, you have very little data loss.
Any more questions? All right, thanks very much, Ron.
All right, so that.
Okay, folks, I'll have a quick 5-minute break. Thanks to Johnny, because he's not actually the speaker we had for this month. The other speaker cancelled earlier this week. So Johnny very kindly offered to step in and talk about tools he's working on himself for bug reporting in that. So a round of applause for Johnny.
Yes. Hey there, everyone. So today I'm going to be talking about something that I'm sure all of us have had to deal with, especially if you happen to work with third-party clients, and that is bad bug reports. I'm sure all of you know the kind of bug reports I'm talking about. One-line descriptions, no steps to replicate, or they don't explain operating system, version of the app they're using, or even what they expect it to do. I just covered my whole talk there. That's me, done. So first, what makes a good bug report? The opposite of everything I just said. A descriptive title. This helps for a number of reasons. If you're looking at a list of bugs, you don't want to have to go into every single bug to get an idea of what that's going to be. It helps cut down on duplicate bugs. If somebody's raising a new bug, they can easily see if a similar bug's already been raised. The expected and actual behavior. So if you're raising a bug, or somebody's raising a bug for you, it's a good idea to explain what you think should happen. The developer quite often think what they have is correct. I do. So it's good to get told this is not what we expect to happen. Instead, it should do X, Y, Z. Steps to replicate. The worst bugs are when somebody comes in, they say, this doesn't happen when I expect it to. When do you expect it to happen? What are the steps? Or they'll say, something doesn't show on the page. You go into that page, it does show. How have they got to the scenario where a promo message doesn't show, or images aren't loading for particular items, or something like that? App version. If the user doesn't tell you what version of the app they're using, they could well be using a version that's from last week, 2 weeks ago, a couple sprints ago. They haven't bothered to update. You're running around like a headless chicken trying to find a bug that's already fixed. Device and OS. Not sure about iOS, but on Android, this will normally come down to whether the worst kind of bugs. Screenshots, especially if the issue is design related, there's not enough padding on this text view, there's not enough space between these two items. A screenshot explaining what the items are, what needs to be changed, it helps. And something that's not possible normally for clients to do, some system logs, network traffic. That's not normally something a QA tester or the clients can be able to do a lot to help, especially if you're passing a bug on to the back end, if you can give what the response they're giving is and why it's wrong. That can help. So an example of a good one, this isn't a real bug report, but so for example here, we've got the title, clearly explains what the issue is. Promotion label doesn't show on items that are meant to be on sale. Somebody coming in later trying to raise that bug is going to see that in the list. They're not going to report it again. Expected actual behavior. Again, what they expect to happen, the promo should show. What does actually happen, it's not showing. Steps to replicate here, going into a specific category, going to a specific item. This item should show, say it shows on the website, doesn't show on the app. And like I said, the version of the app, the version of the device, the model of the device, they can all help. And a screenshot showing a particular item that has an issue. Bad bug reports. Short, undescriptive descriptions. And no steps to replicate. Not helpful for a developer to try and debug what the issue is. No explanation what they expect to happen. They could say, I don't expect this to be happening. What do you expect? So version number, OS, hardware. Again, no screenshots. Duplicate bugs. Having 3, 4 of the same bug just makes the bug queue larger. Doesn't help. So the opposite of everything I just mentioned in the last slide. And here's the same bug that was shown before, just not going to help you try and figure out what the issue is. Promotion label doesn't show. What kind of promotion? Whatever. So how are we trying to solve this in Frame? So a month or two back, the iOS team took it upon themselves to create a library for their apps, which would allow our clients to submit bugs to Bugzilla straight from the app. Not to be outdone, we did the same thing on Android. So what does it provide us? Again, simple way for the client to submit their bugs from inside the app. When they trigger a bug report, it automatically takes a screenshot of the page they're on and allows them to draw on the picture, draw on the screenshot to highlight any features that they are raising the bug about. Logs, something the client normally can't give you. For Android, that would be a snapshot of the log cat. You can see network logs, system logs, any logs that the developers left to see what the issue might be. Accurate app and system information, so versions, quite often the client, they won't know what device they're using, what version of that device they're using. They'll just say Android, iOS, iPhone. So tell you it's Samsung. It's probably the issue. Just a screenshot from when the user first triggers the bug report. So some of the system information has been shown to them there. Screenshots automatically taken, which they can edit, and the logs, which they can view. They can choose to not include these in their bug report if they wish. So the flow that they go through, if they see something wrong in the app, to trigger the bug reporter, all they do is they shake the app. They get a notification asking them, do you want to submit a bug? There's other similar, at least, that when you shake it, take a screenshot of the app, let you submit just to email. So we've kind of taken that idea and then improved on it so it goes straight into our bug queues. And that previous screen, they can edit, they can draw on the images to highlight issues. They go through, they log in using their Bugzilla credentials. They choose the queue that they're submitting the bug for. Maybe several queues for the same app for different versions, different projects. Component. These are all the mandatory fields that Bugzilla needs to submit the bug. So you would choose, say, a checkout component. the version of the app they are allowed to choose, and then we let them enter the title of the bug and the description, so they can enter steps to it, all the stuff that they need to give us, where we deal with all the information that we can get ourselves. So going through all these steps, we provide a bug report that looks something like this. I don't know how I zoomed in there. So these would be the details that the user has entered into their bug report. This is all generated by the library, the app ID, the version of the app, their information, can provide custom information like the environment that the app is running on, staging, live environments, and the screenshots and logs are all automatically attached to that bug once the bug's been created. So it lets the developer have a lot more information from the get-go when they're trying to solve a bug. We don't have to go back to the client, ask them, what were you running this on? Can we get some screenshots? Can you explain what it is you did? Demo. Yes. Don't have the Chromecast in, so I can't show you what's actually happening in the app. But I will submit a bug into this queue for David to fix tomorrow. Backend queue. So I shake the app. Yes, I want to submit a bug. I can draw on the screenshot the items that are wrong. Continue, log into Bugzilla. Choose the backend queue. And write a very descriptive title. And the same for my description. And since I didn't test this, I'm going to hope that it works. Yes. So if I refresh the page now, there's an additional bug in here, already assigned to David. With device information there. I can view these screenshots, see exactly what it is the client wants to highlight as the issue. And for the, I can see the logcat, I can see the response there. So I can, again, as a front-end developer, I can say that's the back-end's problem. The response wasn't correct. Yeah. Yeah, so that's what we're doing here at NFRM to try and make the bug reporting process slightly easier for the client and more importantly better for us to get more information that we need. And it's pretty much it that I've got there.
Any questions for Johnny?
Yes.
Doesn't work on my BlackBerry.
Don't joke. Don't joke. That is
That was one. Push on BlackBerry, then.
push on BlackBerry. That just doesn't work. Generally, stuff that just isn't bugs. We'll get bugs from the QA team or the clients saying this is wrong, and we'll go back. No, these are requirements, this isn't right. Probably the worst kind to get. Yes?
Does it remember your Bugzilla login details? Because I have no idea what mine are.
Funnily enough, when I was trying to get the screenshots for this last night, I couldn't remember mine's either. So I got questioned by Chris this morning why I got banned from Bugzilla at 1 a.m. in the morning. So, yeah. Currently, no. But that's in the works when I get time. iOS already does it, unfortunately.
What would you like to add to this if you had the time?
Remembering password. So I want to automate some of this stuff. The user's having to manage the version. One of the next things, just to, if the version's already in Bugzilla, automatically choose that version, skip that step. Also had a discussion whether we could, there's libraries out there that when a crash happens, instead of the app just crashing, it goes to a different page. So we're thinking maybe if we could open straight to the bug report, let the client submit the bug with what they did, as well as it coming through to Crashlytics. Yes?
How do you keep this out of the live version of the app?
So in the Android, we've got two different build types, two different source sets. In the release source set, it's just got a stub bug reporter class. There's just a few stub methods that don't actually do anything. For all other builds, it's fully functional, has all the functionality. Anything else? Yes.
Are you going to open source it?
Sorry?
Are you going to open source it?
I don't know if that's up to me. I can check.
Okay, very much, Johnny. Okay.